Hello, this is Dr. Matthew Cole, podcast on case study 2 for MGT 5013 business statistics. In this case study, we're going to be addressing the margin of error, which will help you appreciate what we refer to in inferential statistics as statistical significance. In other words, when we say in inferential statistics that a finding is considered statistically significant, we're making that claim because we have set a certain level of confidence within which we are able to make decisions based on our estimation. And case study 2 will help you fully appreciate the standard for the level of significance that we set in social sciences, including business, which is the 95% confidence interval, also known as alpha being set at 0.05. To begin my lecture, I want you to take a look at the PowerPoint slides for Chapter 8 from the Lind textbook, which addresses the central limit theorem. Now, the essence of the central limit theorem is that it helps us appreciate how, when we obtain a sample from a population, and Chapter 8 first starts by reviewing with you some of the common ways with which a sample may be obtained. Samples may be obtained by simple random sampling, or by systematic random sampling, or by stratified random sampling, or by cluster sampling. The important point here is that we're obtaining a sample from a population. With simple random sampling, we're obtaining the sample by saying that each person in the population, or if we're talking about a population of things, each item from that population has the same chance of being included in the sample. And you can look at the PowerPoint to see what some examples are, but what's listed in the textbook is an example where we have a population of employees and we want to select a sample of 52 of those employees. And the way that we use simple random sampling is that we put the name of each employee on a small slip of paper, and then we just pull out one slip of paper at a time until we select the 52 employees that are going to be included in the sample. So each person has an equal chance of being selected, more or less. Another way of obtaining a simple random sample is to use a table of random numbers. And you pick a starting point, and then you will consider that the number of the employee that you're selecting. So in a situation where we have 845, we could use sets of 3 numbers from the random sample. In this case, this is a table of random numbers, and we could randomly pick a starting point. So let's say we just randomly decided to start here. So the first person selected would be employee number 37, and we could just move across in this row, and whatever number works within our range we'll use. So 447 works, 961 does not work because we don't have a 960th employee, 784 works, 189 works. We keep doing that till we've selected 52. So that's one way. You can use Excel to generate a list of random numbers. Another method to obtain your sample from a population is to use systematic random sampling, where the members of the population or the items are arranged in some order. Maybe we say the order is that we're going to pick every fourth member of the population. So that would be systematic random sampling. Stratified random sampling is to first divide the population into groups or clusters, or what's called strata. So maybe we want to organize the members of that population that we just talked about by age groups, and from each age group then we're going to select a certain number of people randomly. So all we're doing is just creating strata first, and then we'll select from that strata. And that allows us to make sure that we have equal representation. We could select a strata, we could create a strata for gender, and we could say if we need 54 people, we'll make sure that we select 27 male and 27 female, for example. Cluster sampling is similar to strata, but it's where in particular we're talking about clusters of geographical locations. A cluster could also be, though, school districts, it could be zip codes, whatever way is available to create a boundary based on something that's naturally occurring in the population. Once we have the sample, then we can start our discussion of the margin of error and how it relates to statistical significance, and then how we can complete case study 2. So we first discuss our appreciation for sampling error. Sampling error refers to the difference, usually an unknown difference, between the sample statistic and the population parameter. Recall our discussions of statistics and parameters, and we said that examples of population parameters are things like the population mean, or the population standard deviation, or the population variance, or the population proportion, and a statistic refers to that same parameter being obtained from the sample. So the mean from a sample is called the statistic bar X. The standard deviation from the sample is called the statistic S. The variance from the sample is called the statistic S squared. The probability from the sample is called the statistic P for proportion. And the difference, so bar X minus mu, is the sampling error. So that's just telling us that if we had available from us every score in the population, and we pulled out a random sample and determined the mean of that random sample, chances are it's going to be a little different than the mean of the population, and that difference is the sampling error. Now what we can do is we can create a sample distribution of the sample mean. And this will help us appreciate the standard error of the mean. So just like we can randomly select a sample from the population, a sample of individuals, or a sample of items, or a sample of scores for all intents and purposes, we can select a sample of means, right? We could say, for example, we're going to take from a population of 100 scores, we're going to pull out a random set of 20, and we're going to determine the mean of that random set of 20. And we're going to keep doing that till we get a distribution of the means. A distribution of the means. So a sampling distribution of the sample means is a probability distribution consisting of all possible sample means of a given sample size selected from a population. And when we do that, that helps us to summarize the probabilities that correspond to the sampling error. Now, when we do that, we end up with the mean of the distributions of the sample means. And if we're going to pull out every mean from the population, we will find that the mean of the distribution of the sample means will be exactly equal to the population mean if we are able to select all possible samples of the same size from a given population. Right? So if we have a sample, if we have a population of 100 and we keep pulling out samples of 20, if we keep going until we're able to select all possible samples, then the distribution of the sample mean will be equal to, well, let me rephrase that, the mean of the distribution of the sample means, right? Because one mean will be low, one mean will be high, one mean will be a little higher. So we'll get a distribution of those means, and the mean of those means will be equal to the population mean. Now, another way of describing then the variability in that distribution of means, right? We're saying here that each score along the x-axis in this distribution of means is a mean. That's why it's bar x, right? And we're saying if we've gotten all of them, then the mean of that distribution should be the population mean. That's why mu is in the middle here, right? This distribution that we're seeing down here in the bottom, this is not the distribution of the population. This is the distribution of the sample means. So the variability, right, the amount of dispersion, the amount of variance in the means from this distribution of sample means is called the standard error of the mean. Right? In plain English, it kind of makes sense, right? We've got some error that happens when we take a sample mean and compare it to the population mean. That's just the characteristic of statistics. And if we are able to get all possible all possible samples of the same size from the population, we will find that that distribution has a mean that equals the population mean, and it has a variance, right? It has a score that refers to its dispersion that is referred to as the standard error of the mean. In formulaic terms, the standard error of the mean is drawn as sigma and then sub bar x. So if we just look at what does that mean, what does sigma mean? Remember, sigma is the symbol that refers to standard deviation. And what is bar x? Bar x is the sample mean. So this symbol here is referring to the standard deviation of the sample means. Now, we don't have to create this distribution to determine that. All we need to know is the population standard deviation, the sample size of our samples, and we take the square root of that. So we're saying that the standard error of the mean equals the standard deviation of the population divided by the square root of the sample size. And from that, so that's where we're going to basically stop with the PowerPoint. Oh, we got to do one other thing. We need to appreciate that there is the central limit theorem. The central limit theorem tells us that if we can get all samples of a particular size selected from a population, we will see that that distribution is approximately a normal distribution once we start to get above a certain sample size, right? So the approximation of this normal distribution gets closer and closer to an actual bell-shaped curve as the sample gets larger, and it starts to become normal as we get to sample sizes of 30 or more. Samples of 30 or more begin to observe normality. What's normality? Well, normality is the nice bell-shaped curve, right? A symmetrical curve. What are the other characteristics of a symmetrical curve? Well, no skew. The mean equals the median equals the mode, regardless of what the dispersion is, right? If we have scores that are very close together, it will be a very steep curve. If the scores are very far apart from each other, it will be a very wide curve, but nevertheless, it is normal shaped. And as we get to sample sizes of 30, what the central limit theorem tells us is that all of the curves start to look like each other, regardless of what the population scores are. And there are examples that show us that. Now, with that then, with the concept of this central limit theorem, put together with the standard error of the mean, we can start to determine ways to estimate the amount of error in any distribution. Even if we don't have all of the even if we don't have the population scores, we take our sample set of scores and we use that to estimate the amount of error in that mean. You know, how close is the mean found in the sample relative to what we would expect to find in the population? And that's what our case study 2 is about. Our case study 2 is going to use a population parameter referred to as rho, which is for proportion, right? The probability. And we're going to find out how accurate is the sample estimate, the sample statistic, meaning P, the probability. So we see the probability all the time when we look at polls. Polls are telling us the probability of voting for something versus something else. So I'm going to start by reading the case study, then I'm going to show you how to complete it. Case study is called Margin of Error, and it says for you to read my blog on how to interpret polls, which will help you appreciate the 95% confidence interval and how it is used in hypothesis testing to determine if the null hypothesis can be rejected when alpha is set at 0.05. You will then pick any 2 polls published in the media and interpret them similar to the manner I describe in my blog. You will write each interpretation as a brief narrative and include the poll's source, meaning you need to cite the poll. Was it from a website? Give the newspaper. Did you see it on TV? So to cite the TV, just give the station, the date, and the time. your essay should address why, quote, the result of a poll must be interpreted along with the poll's margin of error so that the sample size and confidence interval can be determined. I also want your essay to comment on the validity of the results presented in each of your polls using the poll's margin of error. Review my blog for how I have evaluated the validity of the poll results from the last presidential election by using the poll's margin of error. Okay, so I'm going to go through the blog in just a moment. Let me back up and talk to you about null hypothesis. Null hypothesis is a concept that we are going to learn in Chapter 9. But needless to say, null hypothesis is what we're going to use when we start doing our common inferential statistics, such as things like the t-test or ANOVA or regression, or if we're going to interpret the level of significance of a correlation. You can kind of think of the null hypothesis, we've been working with probabilities recently, right? We used the continuous distribution which was the normal distribution. We used the Minitab calculator, for example, to determine what's the probability that, right, 2 home runs were hit, given a mean number of home runs hit in the season. Well, if we were to say, how do we frame that in the language of the null hypothesis? Well, the word null means zero or no difference. So in a probability, we would just say the probability is 0. There's no effect, no probability. So inferential statistics in proportion is when we say we have an idea, we have a best guess, we have an hypothesis as to what the probability should be. Let's say 30% or 25% or 40%. And we will test that against the null hypothesis, which would be 0, a probability of 0. Or it could be even some other value if we want to state the null hypothesis is a particular value. And like I said, we're going to get that more in when we get into Chapter 9. But you're going to see when we do our hypothesis testing, we will state what the null hypothesis is, and then we will try to reject it or falsify it or say that it's not true. The probability is not 0, it's something else. And we're going to be able to have a level of confidence with which we can make that statement that we can reject the null hypothesis. And that level of confidence can be determined by creating a confidence interval around the mean or around the poll or whatever it is that we're working with. That's our statistic. And the most common confidence interval that we use in business and social science is the 95% confidence interval, also known as setting your level of significance at the 0.05 level. The 0.05 level. Another common level, although not as common, but it allows us to be even more confident that we have something significant, is the 99% confidence interval, which refers to alpha at 0.01. Right? You can start to see what's going on here. Now, we talked about earlier in the semester, there's one other thing that we need to bring into this discussion, then I'll show you the poll. We talked earlier in this semester about the empirical rule, which goes in line with all of this. The empirical rule said what? Empirical rule said that approximately 99% 95% of a distribution is within the range of what? The mean plus or minus 2 standard deviations, right? That's the empirical rule. Well, what we're going to find now is that since the word was approximately, we're going to see that the precise value is 1.96. So we're going to learn that exactly 95% of a distribution is within the range of the mean plus or minus 1.96 standard deviation. So this 1.96 is a very important number, and it actually refers to a z. Z equals 1.96. Where does z come from? Remember, z comes from the normal distribution, right? Z is the bar X score, the mean of the sample, minus the mu score, so the mean of the population, right, divided by the standard deviation of the population. That's your z-score. So it's just turning any normal distribution into a standard distribution that has what? A z distribution has a mean of 0 and a standard deviation of 1. Hence, right, almost 2 standard deviations, right, gives us 2 standard deviations above the mean, which is approximately 95%. But exactly 1.96 standard deviations, that gives us exactly 95%. Now that all works together when we start looking at my blog, How to Interpret Polls. So I just clicked on it. Here's the blog. Okay, let's start going through it. Let's kind of review what we had just said in the podcast with a little bit of background. First, purpose of a poll. Right? What's the purpose of a poll? Purpose of a poll is to estimate the opinion or behavior of a population from a sample. Right? When we do a poll, we don't ask everybody in the population, all 300 million people in the United States, the question. We take a sample and we ask them a question. And why do we do that? We work with the sample since contacting the entire population is too time-consuming, too expensive, and practically impossible. As we just discussed, there are methods of sampling. We can use simple random sampling, systematic sampling, stratified sampling, cluster sampling, etc. Now, after the sample is selected from the population, we can compute a statistic that does what? Well, the statistic computed from the sample estimates the population parameter. The statistic computed from the sample that estimates the population is called the parameter or the point estimate. As an example, well, let me rephrase that. The statistics computed from the sample, we had called that a statistic. Another thing that they call that is the estimate or the point estimate. Right? When it's from the population, it's called the parameter, right? The parameter. So as an example, the sample mean, right, is bar X. Bar X is the point estimate, or what we've used so far this semester, we've called it the statistic. It's the statistic of the population parameter mu, the population mean. Now for polls, the sample proportion P is the point estimate or the statistic of the population parameter rho which is the population proportion. So here's the importance of all this. This is the important question. How close is the statistic or the point estimate to the population parameter? This is the essence of this essay, the confidence interval estimate. A confidence interval estimate is a range of values, right? So it's that range plus or minus around the mean. That's a confidence interval. It's obtained from the sample, and it tells us how confident are we that the population parameter is likely to occur within that range at a specified probability. The specified probability is called the level of confidence. And in most cases, certainly with regards to polls, the level of confidence is set at 0.95. And you'll tend to see that because the poll results will always tell you something like 95% confidence or margin of error determined at 95%. And sometimes they don't actually tell you the level of confidence. But I want you to know that if they don't tell you, it is 95% because that's the standard level. And what we see then when we see poll results is we see the poll results, or the probability, and then we see another number next to it, and that's called the margin of error. And the margin of error tells us how confident we are at a 95% level of confidence that the poll, or what we can say the parameter, the true measurement, right, the population parameter, lies within the margin of error. And so precisely what the confidence interval reflects is it reflects the point estimate or the statistic. In the case of polls, it's the poll value, the probability, plus the margin of error or minus the margin of error. Right? We've been working with confidence intervals when we said the empirical rule, right? Plus or minus 2 standard deviations. That's a confidence interval. In this case, instead of saying plus or minus 2 standard deviations, we're saying plus or minus the margin of error, and we're going to learn how we calculate that margin of error. We just learned when we looked at the Chapter 8 PowerPoint that when we're talking about means, the margin of error refers to the standard error of the mean, and we calculate the standard error of the mean by taking what? We take the standard deviation and we divide it by the square root of n. So if the point estimate were the mean, the sample mean, then the confidence interval for the standard error of the mean would equal the sample mean plus or minus the standard error of the mean. And how did we determine the standard error of the mean? As we learned in Chapter 8, again, it's the standard deviation divided by the square root of n. Coming back to the margin of error, we've seen the margin of error when we look at most poll results. So you may see something like the poll has a margin of error of plus or minus 3.1 percentage points for the sample. Now let's make sure we understand what that means before we even determine how we figure out how did they come up with 3.1. Well, if we're saying that the margin of error tells us the interval, it tells us that if we add that and subtract that from the estimate, we'll get the 95% confidence interval. So let's say for demonstration purposes that we have a margin of error of 3.1. Let's say that the poll determined that the probability was 0.5, right? So 50%. If we knew that the margin of error was 3.1, then we would know the confidence interval would be 50% plus or minus 3.1, right? 3.1 percentage points is 3.1%. So a probability of 0.5 means that 95 times out of 100, the true poll results exist within an interval of 46.9% to 53.1%. Okay? This is why it's important, because this will tell us, for example, well, is there really a difference in the polls? Let's say one result was that candidate A, the sample said they'll vote for that person 53% of the time. Then the sample also said for candidate B, we're going to vote for that candidate 47% of the time. Well, yeah, 53% is greater than 47%. But look at the confidence interval. Both of those scores, the 53% and the 47%, lie within the confidence interval. Therefore, for all intents and purposes, there is no difference in how the sample is saying that they're going to vote for the candidates. They're basically saying they're equal. Okay. So now that I hope I've clarified how we use the margin of error and how you're going to express, how you'll interpret the margin of error. In other words, if you have some poll that you find, and you find that, let's bring up a piece of paper. You find that the poll result, right? The poll result said that, a sample of X number of people were polled, and candidate A received 65% of the votes, and candidate B received 60% of the votes. Right? Well, then we might be tempted to conclude that A got more of the votes than B, but we should also see by that presentation of the poll result whatever the margin of error was. And if the margin of error, right, otherwise known as the they call it the MOE, margin of error. If the margin of error was 3.1%, the correct way to present these results is that candidate A has a confidence interval that goes from 60 to 61.9, right? Up to 68.1. And candidate B is 56.9 up to 63.1. That's what I'm saying when I say here that you need to present or interpret your results by presenting the confidence interval. So how would we interpret this? Well, no difference. 65 and the 60 is no difference. They overlap with each other. The 65 really goes down to 61.9, and the intervals overlap with each other. The 60 goes down to 56.9, but it goes up to 63.1. And I just added and subtracted 3.1 from each of those. That's how I got that. All right, continuing back. Now, how is the confidence interval determined in a poll? To determine the confidence interval, right? I just showed you how to determine it for a mean. To a certain extent, we will take the standard deviation, we will divide it by the square root of n. In a poll, what we do is very simple. We will take basically 0.98 and divide it by the square root of n. Right? So the margin of error equals 0.98 divided by square root of n. So let's take that and see if we can figure out what the sample size from that was. Okay, we'll come back over to here. Let's bring out our pen. Start inking. All right, okay, so what did we say? We said the margin of error, right? It was 3.1 percentage points. What actual number is that? 3.1 percentage points is a p of what? 0.031, right? 0.031. What was that equation that we had before? We said that the margin of error equals 0.98 divided by the square root of n. That's the formula. That's what you got to remember. The poll, when you go through the blog, it will show you how this formula was created. We come back to the blog here, and I show you that that's created by that 1.96. There's that 1.96 from the z distribution. That's how we get that 95%. And then it's just this formula of 1.96 times the square root of chance times 1 minus chance divided by n. Right? Chance is 0.5. All right. Needless to say, what's important is that you just remember MOE equals 0.98 divided by square root of n. This is for polls. What's standard error of the mean? Which is another way of saying the MOE for means. It's our standard deviation, which we know how to determine that, divided by the square root of n. Right? How do we determine the standard deviation? Well, we'll just use Minitab. We'll have all the scores. But if we wanted to, it's the sum, right? It's the sum of each score minus the mean squared divided by n minus 1 for talking the sample. All of that is the square root. That gets us the standard deviation. All right, but coming back to this. So now we've got that formula. Let's see if we can figure out how big the sample was. Right? Well, we want to solve for n. All right, so we've got our formula, 0.98 divided by the square root of n equals 0.031, right? Because we were given the margin of error was 3.1. So we have this. Right? Well, we use math. We multiply both sides by the square root of n, right? That cancels out the square root of n here. So now we have 0.98 equals 0.031 times the square root of n. Now we divide both sides by 0.31 and we get rid of that, so we end up with 0.98 divided by 0.031 equals the square root of n. What's that another way of saying? Well, if we square this and square this, what do we get? We get n. N equals 0.98 divided by 0.031 squared. Let's use the old calculator. 0.98 divided by 0.031, right? And let's square that. Squared. 999.37. So for all intents and purposes is 1,000. right? 999.4. I guess if we keep rounding up, if we keep rounding, we would get 0.5. So it's roughly 1,000, right? And that's what I show you in the blog, right? I write approximately 1,000. And, well, let's pick another one. Let's say that they tell us, so we can figure out, do we need more or less people? Well, think about what we just had learned about with the central limit theorem, right? As the sample size gets larger, what happens to the shape of the normal curve, right? As n, right, as n gets larger, the bell curve is going to get steeper and steeper and steeper because there's less and less variability, right? We start getting closer and closer to the mean, right? The mean, mu. So what happens if we double it to 2,000? If we double it to 2,000, are we going to get a larger or a smaller margin of error? Well, let's find out. So now we're saying 0.98 divided by the square root of 2,000 equals, right, our margin of error. That's what we want to solve for, the margin of error. So let's just go ahead and solve for that then. Okay. So 0.98 divided by 2,000 square root and a parentheses equals, well, what did we get? Now we got, so that equals 0.022. 0.022. What does that equal? 2.2%. So did the margin of error get bigger or smaller? It got smaller, right? When it was 1,000, the margin of error was 3.1%, more percentage points. When the sample got larger, the margin of error got smaller. That's basically it, folks. And so now it's just a matter of you putting it all together. So let's look at this example here that puts it all together. A new time poll, this was back in the election, 2008, has Obama holding a 49% to 44% lead over Romney in Ohio. The poll's margin of error is plus or minus 3 percentage points. Okay. So the question is, how do we interpret the results of this poll? Right. Now, what I want you to do then for your case is I want you to solve exactly as you see here. First, second, finally. Okay. So the first thing I want you to do is I want you to determine what was the sample size that was polled. Because normally they will not tell you the sample size. Normally they just tell you the poll results and the margin of error. But I want you to determine the sample size so you're starting to get an understanding of just how many people, or perhaps how few people, are being questioned in many of today's polls. So we're going to estimate the sample size. We know the equation. It's 0.98 divided by the square root of n gives us the n. So we don't know what the n is, but we know that it was 3 percentage points. So the equation would be 0.98 divided by 0.03 squared. So that gives you 1,067, right? Very close to that 1,000, right? 3.1 is very close to 3. So it's just a little bit more. 1,067. Right? As the sample size goes up, the margin of error gets smaller. So going from 3.1 to 3 means we need a little bit larger than 1,000. We need 1,067. So we're done with the sample size. Now we go and we determine each poll's confidence interval at the 95% level. So the margin of error was 3 points. So we take the 49, we add 3 to it, that gets us to 52. We take the 49, subtract 3, that gets us 46. We take the 44 for Romney and add 3 to it, that gets 47. We take the 44, subtract 3, we get 41. So now we put it all together. We decide that according to the results of this poll, a sample of 1,067 people are equally likely to vote for Obama or Romney 95 times out of 100. Why do we say equally? Because the confidence intervals overlap, right? 46 to 52 contains numbers that overlap with 41 to 47. What numbers overlap? The 46, the 47. So that's all you have to do. So what I want you to do in your case study, right, is select any 2 polls published in the media and interpret them by giving me the poll result. I want to see the margin of error. I want to see the sample size. And I want to see your interpretation. If you're given the margin of error, you know how to determine the sample size, right? The sample size comes from the fact that the margin of error equals 0.98 divided by the square root of the sample size. If you're given the sample size but not the margin of error, well then just solve for the margin of error. To solve for n, right, n equals 0.98 divided by the margin of error squared. And then interpret by giving me the confidence interval and then interpreting the results. You may find some polls that have 3, like if you pick a poll where they're doing like Trump versus Hillary versus Bernie or something. You should still they should be giving you a margin of error, and you can interpret it by each one of these needs to have its own confidence interval based on the margin of error, and then you'll find out which ones overlap and which ones do not overlap. Maybe none of them overlap, so which one is then the clear leader? All right, if you have any questions, just send me an email. The other thing you need to do is the quiz for Chapter 8. So there's no mini-tab assignment for Chapter 8. Just do the quiz. The quiz is only based on what I talk about in this podcast. So there'll be a couple questions from the PowerPoint slides on sampling and a few questions about margin of error and standard error of the mean. Thank you very much.